In this video lecture, I would like to discuss the method of reduction of order. You will see and I will explain the name later. The setting is that we want to solve the following second order non-homogeneous equation of the form ax y double prime plus bx y prime plus cx y equals to g of x, where ax, bx, cx, and gx are functions of x. So these coefficients may not be constant anymore. So in previous topics, we learned how to solve second order homogeneous equations and non-homogeneous equations with constant coefficients. And then we have the characteristic equation. For equation with coefficients may not be constant like this, we won't have any characteristic equations. However, what we have is that by somehow we have a solution y1 x to the corresponding non-homogeneous equation. Equation H that I usually write. So we have a solution y1 to this ax y double prime plus bx y prime plus cx y equals 0. For our purposes, in the homework in this topic, you will be given the solution y1. You will be asked to check to verify that y1 is actually a solution to the homogeneous equation, but you will be given. But if we're not given and somehow we can find y1, and that would be good as well. If we have both y1 and y2, then this method won't use y2. We only need y1 to begin with. So the method of reduction of order is as follows. We then look for general solution to the non-homogeneous equation as well of the form y equals to v times y1. Where v is a new unknown. So we introduce a new unknown v, and we look for general solution of the form y equal to v times y1. Our job now is to find v, and once we know v, we multiply by y1, then we get the solution that we're looking for. So how to find v? Well, the next step is to take derivatives, because the equation involves two derivatives. We need to take derivative y prime and y double prime using product and possibly chain rules. Because y is the product of v times y1, so the derivative y prime will involve the product rule, and similar for y double prime. Now let's look at an example to see what's going on. We consider the following ODE. Y double prime minus 3 over x, y prime plus 4 over x squared y equals to x cubed. And we are given y1 of x equals to x squared. So the first things the problem asks is to verify that y1 is a solution to the homogeneous equation. Now it's very important to know that y1 is a solution to the homogeneous equation only. It does not solve the non-homogeneous equation. So the homogeneous equation is this one, y double prime minus 3 over x, y prime plus 4 over x squared y equal to 0. This is what y1 is supposed to solve. Let's check, right? So we have y1 is x squared. So y1 prime is 2x. And y1 double prime is 2. So if we plug into the homogeneous equation, then we get second derivative is 2 minus 3 over x times first derivative is 2x plus 4 over x squared times y, which is x squared, and we want to know is it 0. Of course, we can simplify and we get 2 minus 6 plus 4 equals 0. This is true. It's a true identity. So yes, y1 equals to x squared is a solution to the homogeneous equation. Now we're gonna find general solution to non-homogeneous equation. So we look for y equals to v times y1, which is v times x squared, where again v is a new unknown function. V is a new unknown function. So we need to take the derivative y prime using the product rule here. We have v times x squared. So the derivative of v will be just v prime times x squared plus v times the derivative x squared is 2x, and then v double prime. We use product rule again for this. The derivative one more time for v, we get v double prime times x squared, then plus v prime times 2x. That's the first product. The second product, we use product rule again. We have v prime times 2x plus v times 2. And we simplify to get v double prime times x squared plus, you see that here we have twice of v prime times x and another twice v prime times x. So 4 v prime times x. And lastly, we have 2v. Because we only have one new unknown v, we don't have like two equations like in the method of variation of parameters. Now we will plug into the non-homogeneous equation. And recall the non-homogeneous equations like this: y double prime minus 3 over x y prime plus 4 over x squared y equals to x cubed. So this will be a little bit messy here because the second derivative y prime is complicated. It has 3 terms, but well, just plug in. We have v double prime times x squared plus 4v prime times x plus 2v. That's the second derivative. And then minus 3 over x times first derivative, which is right here. So v prime x squared plus v times 2x. And lastly, we have plus 4 over x squared times y. But y is vx squared. So we have vx squared. And on the right hand side, we have x cubed like before. Now, distribute and simplify things. We will have v double prime x squared plus 4v prime x plus 2v minus here, distributing and simplify the exponent of x. We will have minus 3x v prime and then minus 6v. Over here, the x squared cancel out. Plus 4v equals to x cubed. Now we will collect like terms. Like terms here are in the derivatives of v. So second derivative of v will be one term, and first derivative of v, like this, should be simplified, collected together. And then lastly, we have terms with v. So we will have v double prime times x squared and 4v prime x minus 3x v prime will give us plus v prime x. And for 2v minus 6v plus 4v, they cancel out. And the right hand side is x cubed. Now we have a new equation with unknown v. This is still a second order differential equation. We introduce another new unknown. W equals to v prime. Then this second derivative of v prime here is just w prime, and so we have a new equation: w prime times x squared plus this is w times x equals to x cubed. So then by introducing W, we have a new equation in W, which is a first order linear equation. And this is the reason why the method is called reduction of order. We begin with an equation of second order. It contains second derivative. But by introducing new unknowns, V and then W, we reduce to first order linear equation. But this linear equation is not in standard form. And most of the time, it will not be in standard form. So in order to solve this equation, we need to divide through by x squared. Okay? To make it in standard form, then we will have W prime plus, divide this by x squared, we have 1 over x W equal to x. So this is first order and in standard form. Now recall one of the previous topics in the chapter about first order equation. We have a first order linear equation in standard form. This is W prime plus Px W equal to Q of x. Here our unknown is W, so I write the format of the equation in this form. Px is 1 over x and Qx is just x. So to solve this equation, we need to find integrating factor. Integrating factor mu of x is given by e to the integral of 1 over x dx. So we get e log of x, and we can simplify to x. So as before, when we find integrating factor, we may skip the absolute value, so it's easier for it to work. Now we're gonna multiply standard form through by x. So multiply the standard form through by the integrating factor x. So multiply each term by x, we will have x times W prime plus, multiply this by x, this will be gone, and we just have plus W equals to, don't forget to multiply on the right hand side, we get x squared. And then the whole thing here can be written as the derivative of a product W times the integrating factor, and we get x squared on the right hand side. Now integrate, we have W times x equal to integral of x squared dx, which is 1/3 x cubed plus a constant. Now for the purpose of naming the constant later on, I would label this constant as C2, and you will see why. And now we solve for W by dividing through by x, and we have 1/3 of x squared plus C2 over x. So we solve for W. But we have introduced two unknowns. We have solved for W already, so now let's go back to V first. What is V? What is the relation between V and W? The relation between the V and W is that W is V prime. So that W should be replaced by V prime. So V prime is 1/3 x squared plus C2 over x. Now we need to integrate again to get V. So integrate, we have integral of 1/3 x squared plus C2 over x dx. And so we get 1/9 of x cubed plus C2 times integral of 1 over x will be natural log of x. And again, we need to add a constant c, which I will label as C1 in this case. So now we have solved for V. But this is not the final answer yet. The final answer is Y. Okay? And so we get back to Y. This is our unknown we wanted to solve. Y is V times x squared. If you recall, that's what we started with right here. Okay, Y is V times x squared. And we already know V, so now we just multiply V by x squared. The whole thing here by x squared. So 1/9 x cubed plus C2 natural log x plus C1 times x squared. And as before, we need to distribute to rewrite the solution in the familiar format C1 y1 plus C2 y2. So let's try C1 first, y1 x squared, and then plus C2, we have x squared log x. And lastly, plus 1/9 x to the 5th. So we have the format C1 y1 plus C2 y2 plus capital Y as we usually have. But we have used the method of reduction of order to solve the problem. We now look at another example. We want to solve the ODE. Y double prime minus 2 plus 1 over x y double prime y prime plus 1 plus 1 over x y equals to x squared e to the x. And here there's a technical condition on the independent variable x positive. And we're given y1x equals to e to the x. So as before, we will need to verify y1 is a solution to the homogeneous equation. The y double prime minus 2 plus 1 over x, y prime plus 1 plus 1 over x, y equal to 0. That's the homogeneous equation. So let's verify that. We have y1 equals e to the x. So very easy. y1 prime is also e to the x. And y1 double prime is also e to the x. And then we plug into the homogeneous equation. we will have e to the x minus 2 plus 1 over x e to the x plus 1 over x e to the x equal to 0. And is it right? So over here we can distribute in and verify. We have e to the x. Don't forget the minus sign. We also need to distribute the minus sign. We have minus 2e to the x, and then minus 1 over x e to the x plus e to the x 1 over x e to the x, and is 0. So it seems that everything cancels out. So we have 0 equals 0, which is a true identity. So the conclusion is that y1 equals to e to the x is a solution to the homogeneous equation. Now the next step is to find general solution to the non-homogeneous equation by using reduction of order. So we look for general solution to the non-homogeneous equation in the form y equals to v, the new unknown, times y1. So it is v times e to the x, because y1 is e to the x. And as before, v is a new unknown we need to find. Take the derivative using product rule. We have v prime e to the x plus v times e to the x. Second derivative will be v double prime e to the x plus v prime e to the x. That is for the first product. For the second product, we have v prime e to the x and then v e to the x. And we can simplify to get v double prime e to the x plus 2 v prime e to the x, and lastly v e to the x. Now we need to plug these derivatives into the non-homogeneous equation. Plug into non-homogeneous equation, which is over here. So second derivative minus this times fourth derivative, and then plus this times the function equal to x squared e to the x. So it's that one. Second derivative is the whole thing here. V double prime e to the x plus 2v prime e to the x plus v e to the x. And then minus 2 plus 1 over x times the first derivative, which is here. V prime e to the x plus v e to the x. Lastly, 1 plus 1 over x y, but y is v e to the x, and on the right hand side we have x squared e to the x. Now we need to distribute and simplify. We have v double prime e to the x. I'm just rewriting the first three terms here. 2v prime e to the x plus v e to the x. Then distribute. When we distribute, don't forget the minus sign. So gonna be minus 2 v prime e to the x minus 2v e to the x. You need to be very careful when doing this algebra, because if you make a mistake, everything after this would be wrong. Minus 1 over x v prime e to the x, and minus 1 over x v e to the x. And then it needs to distribute here and there. So plus v e to x plus 1 over x v e to the x. Right hand side is still x squared e to the x. Now we need to collect like terms and simplify. As before, collecting like terms means that we look at terms with derivative of v. So this is one term, and we don't have any other second derivative. So rewrite that v double prime e to the x. Next, we look at derivative v prime. So these are the terms with v prime. We see that the first two cancel out, and we have left with minus 1 over x v e to the x. And lastly, terms with v. So plus v e to the x minus 2v e to x, and here, here, and here. So it turns out that these cancel, and also this cancel, equal to x squared e to the x. Now, in general, with the method of reduction of order, all the terms with v will cancel out except v double prime and prime. These are the terms which may survive. Okay? If you have v left, then there is a mistake somewhere. Now for this problem, we can simplify a little bit as well by dividing everything by e to the x. We get v double prime minus 1 over x prime equal to x squared. So now we have a new equation in terms of v. It's still a second order equation, but as before, we will introduce new unknown u equal to v prime. Then we get v double prime is w prime minus 1 over x v prime is w equal to x squared. This is first order linear equation, and can use the method we learned earlier to solve. For this first order linear equation, we have p of x is, don't forget the minus sign, which is minus 1 over x, and q of x is x squared. So the integrating factor is mu equal to e to the integral of minus 1 over x dx, and we get e to the minus natural log of x. And as before, we don't need to use absolute value. The minus sign should goes in the exponent to get e to the log of x to the minus 1. And now we can cancel out e and log to get x to the minus 1, which is 1 over x. So the integrating factor is 1 over x. And now we multiply standard form by 1 over x. Standard form is right here, and we need to multiply through by 1 over x. So we get 1 over x W prime minus 1 over x squared W equal to 1 over x times x squared. We get x. And then the left hand side is the derivative of product W times integrating factor, which is 1 over x. And we have x on the right hand side. Now integrate. We get x squared over 2 plus the constant, which again I will denote by C2 here. Now we solve for W by multiplying everything by x. We get 1/2 x cubed plus C2 x. But recall that W is nothing but V prime. So we have V prime is 1/2 x cubed plus C2x. So we solve for V by integrating. We get 1/8 x to the 4 plus 1/2 C2x squared plus C1. Now we have solved for V. Then we get back to our original unknown y, which is V times y1. But recall y1 is easily x. So we have y equal to 1/8 x to the 4 plus, let me write C2 and 1/2 x squared plus to C1 times e to the x. But as before, we need to distribute and rewrite in the format C1y1 plus C2y2 plus capital Y. So it is C1 e to the x plus C2 1/2 x squared e to the x plus 1/8 x to the 4 e to the x. So our y1 is given e to the x, and we have found also from this formula y2 is 1/2 x squared e to the x. And lastly, capital Y is this 1/8 x to the 4 e to the x. Now sometimes we may combine C2 and 1/2, C2 times 1/2 into a new constant. Then we may rewrite the solution as y equal to C1 e to the x 2 x squared e to the x plus 1/8 x to the 4 e to the x with a different constant C2. So in fact, our new constant C2 here is 1/2 of the old constant C2. So for we may read like this to make it simpler, but you don't need to do so. You may use this format as the final answer. So this is the end of the video lecture.